There we go. All right. So this is around managing detached payloads, or managing payloads in general in a cozy envelope or a SCITT signed statement. And there's a couple of different approaches. And as we were overlaying SCITT on our data trails APIs, we started tripping over some interesting questions around how do we handle varying sizes of payloads, and some that can be large. So that's how this presentation came up. The more I drilled into it and got into the details and some of the round robin of how we were thinking about it, I went back and looked at Ori's proposal a couple months ago, and it looks amazingly similar. So it's the same elements, it's just a matter where they are in the header or not. So we'll review that in a bit as well. So just as a quick recap, because it puts the context to these, is SCITT is about identities, the who's that make immutable statements about an artifact and recording those at a point in time. Who are the who's? Well, not necessarily the whovilles, but the who's from whoville, although those are identities as well as anything else that you might need an identity about, from individuals to companies to groups. And depending on the situation and industry, you may or may not want it to be specific to an individual. But basically anything that has a type of an identity, including a build machine. While we lean into X509 as a default one, not a default, but a known one in SCITT, there's nothing tied to X509. In fact, the issuer is just a T-star, and you can put whatever identity string you need there. And depending on which identity type, you might put additional headers in there. So for X509, there's some, I guess you could call them required properties when using X509, even though they're optional because of SCITT. It doesn't require X509. And then what are the statements? Well, it's anything you want to be able to say about an artifact, from an SPOM to a contract about a couple of parties, a C2PA, as we were discussing previously, AI model cards, statements you want, model cards around a model, basically, anything you need to be able to describe around something else. And the something else being the artifacts that you're describing, could be, binary data for software, as we've been talking about, could be AI models, virtual conversations, digital media such as C2PA, or physical goods. We track nuclear waste with data trails. So it's all around anything that has some kind of identity. So here in SCITT does not define what the identifier is. It's up to the industry or vertical or whatever it might be. So the format of the subject is not part of the SCITT architecture. It's really up to each industry and how they do it. And then the subject is the identifier there, and now you've got the two of the issuer making a statement, which we'll talk about the payload, about a thing, and that's the subject. So if we bring these out to the to be signed bytes, we've got the issuer and the subject, and then those are in the protected header. And then I brought up some other properties because of in this case, we'll use X509. And you have the identities, the properties of X509, so that it ties back to the identity or the issuer. And then the statement's content type can be placed in the protected header as well. And this turns out to be fairly useful to be able to know how you're going to parse the payload. And then the payload itself, and I'm air quoting because this is the main part of the conversation, would be in the header as well. So you have the protected header and the payload. Those are the to be signed bytes. So if we take our key and we want to sign it, and I should change the animation so it shouldn't really be the whole envelope. You're taking just those two elements, the protected header and the payload. You sign those, and then you're putting it back into the envelope as the actual signature. So that signature is representing the protected header, the protected property, and the payload. There's an unprotected header that is useful for sharing information as well, and we'll see how we can use that. So now when you go to register, a sign statement, because this has now been signed. This is the first time it actually gets submitted to the ledger. It's already been signed. We want to go and verify that that signed statement. Now, this is where it starts to get interesting, and where it popped up for us with data trails, because we take this statement, we were mapping the payload to our metadata properties, because in data trails, we use the ledger not just for recording something, but there's name value pairs in there. There's attributes that get recorded. That's what our customers wind up valuing, is that they can record certain information that we could then index. So how large is that signed statement? Now, the protected header, that's about a K, nothing really of interesting size. The signature, also about a K. It's like, yeah, whatever, kind of fits in the current schemes of today. Don't really think too much about it. And the unprotected header probably has nothing in it to start with. The payload starts to get a little more interesting, because it could be a couple of name value pairs for some attributes, or it could be a container image, or a large language model, or a vcon's actual conversation. So now we're starting to see there's a very large range of what those statements could be, which is by design. But is it just the size that's the constraint? Is the statement actually already stored somewhere else, and are we starting to be duplicative of where we're trying to put statements, the content, and where is the source of truth? So it's multiple things, not just, should I want to record this yet again, but do I need to have it in another location? So what value are we getting by putting the actual statement in the signed, the actual content into the signed statement? So interestingly,
Cozy has just that slide for a second, because that was a good slide.
I was about to say, by all means, interrupt with any questions along the way. Go ahead.
For it. Got it. Thanks.
You wanted me to go back. Sorry, was there a question?
No, I just wanted to get a screenshot of it from my own mind for the moment. I know we'll get to see it in the future, but
okay.
Yeah.
Gotcha. So, Cozy defines a payload that can be nil. You can empty the payload so you can share the envelope more efficiently, which sounds great until we start layering in how we think about this with SCITT, is we're trying to verify that the signed statement as it gets registered is from the issuer and has, an integrity check, and basically we're trying to verify that statement, the signed statement. You can't verify the to be signed bytes if they've been nulled out. We're missing that piece of it. So the way Cozy defines this is that you can null it out, pass it around, but you need to reconstruct it if you want to actually verify it. So at this point, this verification is going to fail because it's nil. Now, in the unprotected header, we could put the location of where it was. So I just suggested here might be an SBOM SH. That's fine. Here's a hint. Now the server can go get the null payload, and as long as that really is the payload, then the signature will be verified and life is good. If, there's a big if I have access to that location, because that location might be locked down from credential perspective, the SCITT instance might be inside a firewall and I don't want to have any egress or ingress to it. So it's not just a size constraint, there might be security boundaries as well. So what value, did this really work out as reliably as we want? Now, when we think about these transparency services, there's actually multiple ancillary services. So in data trails, we have an indexable metadata store. That's how this conversation actually popped up. And we have blob storage, which can also be, storing what we call attachments. We don't consider ourselves a storage service. These are just the ways we round out part of the services, and we recommend you should be using other storage services, such as these external ones. In the software space, we already have lots of everything from NuGet and NPM, and where they store large language models, or OCI artifacts, or all these different things where things are stored. We don't want to move the cheese of where those things are. So the content of the statement can be kind of interesting on the different types of payloads that you would set. So it might be just some inline content, simply like not even a file. I just literally say foo equals bar, and that's the top one for inline binary. Then you might have a small file. Well, define small and define large. It varies based on the industry or the scenario. It also varies on time. Several of us remember 1.4 megabyte floppies. That was my operating system or the application, and now we can't even get a picture to fit on a floppy. So time changes as well. It might be a collection of files, which are large and small files, by the way. It might be a reference to a URI, whether it be a Docker image, a package, a YouTube video. Any number of these things have intentionally unique or floating references. So in this case, we're talking about unique references. Or for many of these things, they already have a manifest that defines the collection of files, large and small, with unique identifiers. So for all of these scenarios, what would we put into the payload to actually put an identity around these? So I've kind of broken this up into a couple of different scenarios. So you could just put it inline, which is what we generally think about. And I would literally take the inline content, stick it in there, or take the manifest or collection of files and compress them and put them, not compress them, but serialize them and put them inline. They could be a detached payload, but it's null. So it's basically it's inline, but I get to blank it out. So that really isn't any help. Where we've been going with this is, should we just hash the payload? So now we can get an identifier or a representation of the payload itself, but we don't actually have to pass the multi-gigabyte file around and have a duplicity of it. You're basically take a hash of it. I can now do the verification. And then when I want to actually get it, I make sure that it is the same hash. And can we get a good balance of both? The proposal that I've been doing here is that the payload is the hash of the content. The content type is whatever the original bytes were. So this is the pre-image, if you will. If it was a JSON file, fine. If it was an SPDX, if it was a VCon, whatever the content type of it before it was hashed, that's what would go here. You'd have your hash algorithm, whatever that might be, because that'll change over time. And then there's this, I've been struggling to call it a hint or not, but basically when this thing was signed, you can put a location to say this is where it was at that point in time. And I'm being vague about the location because location should not be the identifier. This is their whole decoupling identity from location has been a large conversation that is in the Perl community and that we started back a couple of years ago now, because I want to be able to copy my content to where I'm using it. So the content is still the same, the location could move. So there's a whole long conversation there. Okay, so then the question is, can hash be that answer going forward? And while you could still put it in line, it starts to make it kind of interesting if I can be consistent with it, because now I don't have to do a bunch of switch statements on when it's one way or another. So the sign statement is consistent across all the services. I don't have to worry about some service, supporting 1 megabyte, another one storing 50 megabytes of a payload. And if I try to take the 50 megabyte sign statement and I copy it to a private instance because I'm trying to have an isolation barrier, that service may fail. So I want to be able to have a consistent way to think about it and still use the existing storage services. That's the third bullet there. And the transparency services can provide them, and then if they do provide that storage service, then they just say, well, here's the URL to that storage service. It's still a hash, so it's consistent.
I'm trying to understand what you're distinguishing there. So in other words, what do the bullets relate to there? And I guess at this point, I'll even go back and say, like, why would nil ever be an option?
So great question. So the nil is set up so that you can pass around a signed statement that is abstract of how you want to handle it. That's just part of the COSI specification. So when we were looking about this and trying to detach payloads, COSI defines attached payloads as nilling the payload statement, payload property, and then you have to reconstruct it. The more we went through it, well, if I'm to reconstruct it, to do the verification, to your point, you still have to bring the payload in, so that it's an optimization that depends on where you are in the workflow, if that works for you. And what I'm suggesting is in the SCITT scenario, I don't think it works really well.
So is there, where are we in terms of specification? Is someone proposing to not allow nil and to require either inline or a hash?
I wouldn't say require, because we never want to limit somebody per se. We would probably, my proposal is that we would put this up as a draft. Ori's already started one, and that be a profile that you could use with SCITT. So this way, if somebody comes up with another scenario, that nil is used somehow a different way, that's fine too. But this would be a profile that you'd be able to use with SCITT.
Great. I see hands up, and I'm probably not following etiquette. Go ahead.
I'm not seeing hands up. So whoever's next, where's
Alex? AJ has a hand up. Somebody else did.
Yeah, but I thought someone was before me. That's why I was surprised. Surprised. Wasn't there someone who?
Oh, there it is. I see it. AJ, you're up at this point.
Yeah. So part of my confusion with this, if we're going to talk, I think this is a useful presentation, and I know I've been a skeptic when you've talked about this to me. You also posted, and you've alluded to another draft. So from what I can tell from the SCITT architecture, if we talk about like the IETF things we should be aware of and this community is interested in, there's the core architecture draft for SCITT, and then there is the use cases. And then notionally, there's this opinionated API thing called Scrappy. So those are the three specifications that dictate different parts of the elephant of SCITT. Everything you've talked about is actually, and I've asked in the official IETF mailing list because I'm confused about some things, all the other things are reasonably deferred to different specifications. And it says, if you want to know about the options you have for doing those, and which one we recommend or which several we recommend and what we don't recommend, those are actually dictated in drafts for COSI. One of them around hashing and signing, one of them around signing, and one of them about, I can't remember the other thing off the top of my head. Part of the confusion I have is all the things that we're talking about in this around the mechanisms really depend on how you're signing and what you're doing in the signature fields in the current version of the draft. And no one has really clarified for me. I've read, but I'm not really 100% sure. It's obvious to me what the signature options are. But if it's a public key signature system, part of the deal with that is that you're digitally signing a hash, and there's like an inversion of keys. So you get the hash for free when you have something inline. So
for free. But
I've spent the last 10 minutes trying to find a visualization of generally how do digital public signatures work in a way to make this conversation less confusing to me. But like, so when you want to show someone a when you want to show someone as something to be verified as a digital signature, If it's using public key infrastructure, you do the opposite of encryption. So you sign it such that someone can take your public key because they've confirmed that you're Steve Lasker. So let's say I'm AJ and I want to know that when you sign something, I know that SCITT doesn't often work this way. We think of issuers as not individual people, but usually an organization. There's nothing really saying that or not, but that's a ancillary topic. It's not really interesting. So like, let's say Steve signed something, and I want to verify it. It's actually encrypted with the private key. Sorry, signed with the private key such that I would decrypt it with the public key of you, because I'm making some assumptions in my security model that I know this public key that Steve has, and I trust Steve. So when I decrypt that, I'm going to get a hash. In most signature systems, the key problem is we haven't really specified which ones are the options in SCITT officially off memory, and I couldn't figure out which ones were actually valid from the two drafts because I wasn't paying attention. And then you should actually validate that the signature that you generate matches the one that was digitally signed. And the way I would know that is because I'm basically using your public key to say that you're Steve. And when it decrypts, I'm going to see, I'm like, oh, there's this hash, and I can decide whether that hash lines up or not. If we're on the same page about that, I'm not really sure what's gained from having the third hash variant so far when we have two. I haven't read enough to know if I'm off base here. The third thing is that you recently mentioned a draft, which I can put in the chat, and it is similarly worded and makes me think that there is no explicit hash defined the way you're expecting here, because you get it for free. I tried skimming ORIs while I was at an appointment, so I could be wrong here. But that's part of the pluggable architecture of SCITT. So I've kind of rambled, but it's not clear what's supported and not supported because we haven't talked about the related drafts and the mechanics of what goes in a signature or payload. And you're overriding something that's the meaning of payload in one place where you might be adding duplicative content. That's basically the summary of what I'm trying to propose here without being 100% confident the details in about 4 places. And that's why I wanted to have a longer conversation about it. But that's just my take. I don't have an expert take on this. I'm going to stop talking. That's my first impression of this.
So before I answer some of the questions, I see Neil and Robin both have their hands raised. So Neil, you're up.
I'm curious about what AJ says. I think I would push back again without having verified sources yet on this notion that like all public signature algorithms work in a way that you can invert public keys and private keys. I think I saw recently a discussion that says, yeah, that used to be true for RSA, but that's not really true for some other things. So I'll just push back on that piece.
No, I agree, but that's why I said totally. The problem is I have to go look, but in the documents, there are 2 related documents, one for COSI and one for another set of algorithms. If you read the SCITT document, it doesn't tell you which ones are supported. It says, I defer to these documents, and you have to go read the registries of them. Then you have to read how those work. So I'm saying, given the public mechanic or the general mechanics of how you might think some of them work, it really is it depends on which ones are actually required and or possible in the specifications for me to have a real opinion about what Steve is proposing here.
Yeah. Okay. Go on.
Yeah.
Robin?
Yeah, I just wanted to ask what if AJ was pushing back on the idea of uploading a hash instead of uploading the content on the basis that signature algorithms produce the hash anyway in many cases. Is that what you were suggesting?
If I find enough information to know that's the case, yes.
Okay, so in the case where the thing that you're pushing up to make the digest of is very large, you're not concerned with that situation.
Oh, I didn't see it's at the beginning of the deck. 2, back to the thing that Robin is pointing out. I don't know what that affords you because inevitably, regardless of where you put the hash, you either have the ability to verify it or you don't. I thought the layering of the signatures presumes something in the security model about whether you trust the issuer or not. If you read the specification, I think you're required, if you're starting a transparency service, I think it has to verify the signature. I don't know it actually has to actually, this is a good point. I guess I have to reread because if you have to verify the signature with a offline or detached payload, I'm not sure what you're actually verifying. but I have to go read the drafts. So I didn't get clarity from reading them on and off for the last few days when Steve and I discussed this, which is why I was going to start answering questions or asking questions for answers on the mailing list for my own edification. My point is, Robin, I couldn't tell you I'm not that well read, or I would have a much more confident answer, but that's my hunch thus far.
Got it.
Let me do one more slide because I think if my memory serves, this answers the verification part. So in the SCITT statement, you have the protected header. Let me remind myself what I was doing here. So that's the protected header. There's the hash. The payload becomes the hash of the content. The signature is of the protected header and the payload. So AJ, to your point, yes, the signature the signature itself is a hash over the to be signed bytes. To verify the signature, you need to reconstruct that content. So if you're signing the payload, the 1 GB file, then in order to verify the signature, you need the 1 GB file to actually reconstruct the to be signed bytes. If you have hashed the 1 GB file to begin with, and you're signing the hash, then all I need is the hash to be able to verify the signature. So it becomes a second step. Now you basically can say, all right, I verified the statement, the signed statement, but I've only verified that there's a hash. There is a secondary step that you have to then say, okay, does the hash of the signed statement actually match the content? So you do need to go do that in order to make sure that the verification is complete for the integrity of that content. And that's a choice that you're making. It turns out we make that choice in a lot of places. That's the whole way the OCI stuff is signed, is you're signing manifests, which are all hashes, and the client must verify that hash matches the actual hash of the content, or you've left yourself open to another hack. So that's all this is saying here is, well, it basically just recaps that the signature is over the protected header and the payload. And if it's just a hash, then I don't need to reconstruct it. If you want to at some point, so for instance, you want to make sure this hash does match it, if you have access to the statement location, you can pull it and check it. The assumption here is at some point you are trying to do something with this content. So whether the content is at this location or another, you're still going to verify it. So as long as the hash of that content, because I get it from my private instance of that storage service, as long as that hash matches the hash in the payload, then I'm good to go and life is good. So that's the last slide of the deck. And I'll go back to the queue. I see, AJ, you put something in there.
All I put was the relevant quote from, I think, the part, I point out that it says you need to know how to do these things, but none of that is in the SCITT architecture. It's in another document. How that pertains to detached and the inline was not clear to me after reading from several times, despite quote unquote how smart I am. Thank you, internet. If you see this, you'll find out my humility and honesty is paramount. But that was the deal.
So I seen Robin, but I post something here, but Neil, you still had your hand raised.
Yeah, so I just wanted to incorporate those things. So I agree with what Steve said, which is that the hash that you would get out of the digital signature is not a hash of the payload. It's a hash of this combination of the the other stuff plus the payload. So if somebody wanted to know just what is the hash of the payload, this thing that I can't look at, then I think it's perfectly helpful, very helpful, to explicitly put that in the statement or envelope or whatever it is. I always get confused about this. So I think having that hash explicitly first of all, it doesn't cost hardly anything. You know, hashes are pretty small. And second of all, would even allow like new forms of verification. I don't know if we want to really push these, but if somebody wants to know that somebody really did sign something and still is not going to get access to the payload, but has somebody that they kind of trust only from the standpoint of being able to verify that the payload matches something important and valid and of interest, then they could say, well, I'm going to verify everything except that the hash is right, and I'm going to trust you to verify that, and now I'm going to be satisfied for whatever my threat model is.
So the other piece that comes into that is what I refer to as the Trojan horse attack situation. And this was a big thing in the container space. I want to be able to verify the identity of the content before I even pull it. So this is where in the SCITT scenario works really well is that I can go and pull the signed statement. I see who the issuer is. If I don't trust the issuer, I'm not going to go pull the content. If I pull the content first and then I start to verify it in a container image or any other binary, well, it could be any other content that I can embed binary in. Once I pulled the content to my machine, all I need is another attack vector to then activate that content. Using this kind of mechanism, I can first see, all right, this is the reference I'm trying to make. Hey, SCITT, do you have an identity for this? Is it from an identity I trust? Yes. Okay. Now I've done some verification. Now I could pull the content and I'll compare that the content matches the hash. And as long as that's done, I can now continue. So that's just rounds out the situation. But to your point, Neil, unless you have the hash of in the payload, you can't actually do the verification. I think that's, AJ, I think that's the piece that we're kind of circling around a bit. And if I multitask here and read.
Well, I think I would agree with Steve that you could, even without an explicit hash there, you could do whatever you think you need to do to reconstruct how it was signed and pull all that together. And then also pull the hash out of the signature algorithm if you happen to know enough about how that's how to find the hash in there, which I really don't want to complicate verifiers with that. And then you'd be able to say, yes, they match. But I think your point is exactly right, that you don't want to have to force people to get the payload to get any kind of verification. So, I wonder if we want to try to get to Nikos today in the remaining 15 minutes, or if there's something else pressing here.
Well, 15 minutes is enough for me, but if you want to continue the conversation, I can talk at another time.
We can continue it off, as people can watch the recording, we can continue it on the SCITT community conversation or even the SCITT alias. There is like I said, I brought back to here, there is Ori's draft. Let me bring that over here. And in fact, we need to act on it because it'll expire in July. And so it looks amazingly similar. I haven't actually looked at this in a while, so whether that was in my head subconsciously when we finish this up or not, it comes around the same aspects. So I'm using this as a point to round it out, and let's continue to have the conversation. And I'll post the deck to the SCITT community, and we'll have the recording. And Nikos, I'll give the rest of the time to you.
Great. So can you also just post that the link to the Ori's draft, and then
it's in the deck, and I'll post them. I'll post them all together.
I mean, just here in the chat. But go ahead.
Oh,
go ahead, Nikos. Thank you.
So just to bridge the two discussions, I'm involved in a project where we were trying to build a security solution for tracing firmware updates. So initially we were planning to use SCITT, but it was early days of SCITT, so we jumped to SIGSTOR, which at that time was more mature. So initially, SIGSTOR was recording the whole artifact in the registry. But then, and probably, I don't know if they have changed it already, but they decided to stop recording artifacts in the registry and instead record hashes, digests of artifacts. One reason was what Steve said. It was related to the size of artifacts, but there was a second reason for making this decision. They decided that recording artifacts in the registry is a security and privacy risk because the registry is immutable and attacks can occur due to information recorded in the registry. So they decided that the less information is recorded in the registry, the better for a security and privacy perspective. So maybe this is something that can be considered.
Great.
Now, yes.
Yeah, we've discussed this with SCITT as well, is basically only hashes go onto the actual ledger because it's append only. And you have everything from PII data to data that might get redacted and so forth. So if you have just a hash of it on the ledger, you could even salt it and do other stuff so that you can't even reconstruct it and re-verify it from a hash. But that's where I was kind of showing that the ancillary services, you might have a metadata service, you might have a storage service. So in data trails, we actually store the signed statement in an ancillary service. It's not actually on the ledger. So we could redact the actual signed statement, but you would still be able to verify that it was put on the ledger at a point in time. So it's kind of that balance of both.
So let me share. Can you see my screen?
Yes.
Yes. So related to what was written in the HackMD document about how SIGSTOR uses OpenID Connect and identity providers. So from a very high level perspective, SIGSTOR includes a collection of tools. There is a tool called cosign that signs artifacts. It generates a key pair, and then it communicates with a certificate authority called Fulcio. Fulcio asks user to log in and with an identity provider and issues a short-lived certificate, which is recorded in a certificate transparency registry. So this certificate transparency registry, it's not the same registry where information about artifacts is recorded. It's the same certificate transparency registry that browsers are using. So in order to add your own identity provider, either you have to make a pull request to Fulcio GitHub repository and convince the people there that you are operating an identity provider that matches certain criteria, or you can run your own private instance of Fulcio. Just as a next step, Cosign signs the artifacts and publishes the digest of the artifacts in another transparency registry called record. So what is happening if you are running your own private instance of Fulcio? You can do everything except from the certificate transparency step. So the certificate transparency currently accepts certificates only issued by the public instance of Fulcio. So You can run your own instance of Fulcio. You can attach to it very easily your own identity provider. You are missing the certificate transparency registry, but you can still publish artifacts in the record transparency registry. So how important is this first step? How important is publishing certificates in the certificate transparency registry? This prevents attacks where the certificate authority is misbehaving. So by publishing certificates to the certificate transparency registry, as you probably know, allows you to detect misbehaving certificate authorities. Now we learned something very important that maybe it's also a useful lesson learned for SCITT as well. While certificate transparency is a very nice concept, in reality what is happening is they operate as another centralized trusted point. Verifying the status of the certificate transparency is very complicated. Although it appears that you have only to verify the root of a Merkle tree, in reality, there are much complex operations that have to be performed in order to be sure that everything is correct. You must verify the root of the Merkle tree from multiple vantage points, and then you should have all these vantage points gossiping what they have learned, and from there deciding whether the certificate transparency operates honestly. And this operation is so. Another thing is that whenever you push a certificate to the certificate transparency registry, because it needs some time to be recorded, what you receive back is a promise that the certificate will be included in the registry. So what is happening currently in the existing WebPKI, where this technology is also used, is that browsers examine if a certificate includes this promise. Now, because examining the security status of the certificate transparency is so complex, browsers simply just trust this promise. They never examine if this promise has been fulfilled. So, in other words, certificate transparency registries become another centralized trust entity. And because SCITT also considers transparency registries that are using the same Merkle tree data structure, we should be aware that there is also the danger there, or maybe it is not in danger, that we will end up blindly trusting these transparency registries, and it will be very hard to monitor their security status. So that goes a side note. We wanted to develop a web service that offers SIGSTOR as a service. So we created a website. The website is the one that appears at the bottom of this page of the slide, where the user uses a web page to upload the file. The web page calculates the digest of the file and invokes a private instance of Fulcio certificate authority, calculates a signature over the uploaded digest and records this signature to the record registry. So what we did here is, because we are using already a service for authenticating users to this website, we didn't want to use another redirection to the identity provider in order for the Fulcio certificate authority to receive this identity token and issue the short-lived certificate. What it turns out is that the Fulcio certificate authority provides a REST API that can be invoked. And this API accepts as input a certificate signing request as well as a valid identity token. And this is how we use the certificate authority. We authenticate users at we authenticate users here. We generate a valid identity token, and we are calling the API of Fulcio, providing as input the key that we are generating here and the identity token. So from the user perspective, the user is not directed to another login process. So this is another useful property of Fulcio. That was a super quick introduction of what we did and our experience with Sigstore and the lessons learned.
Thank you.
Yeah.
I see Robin's
Robin.
hand up.
Yeah.
Yeah, I wondered if Nicholas could elaborate a little bit on what properties he needed from the certificate transparency part of that block diagram in terms of integrity and verification and so on.
Okay, so our attack model where a state-sponsored attacker that has access to the certificate authority issues a valid certificate but malicious certificate, and then uses this certificate to sign a firmware. Now, if you have the certificate transparency in service, you can detect the attack at the very beginning, where the malicious actor generates the certificate. Of course, for this attack to be successful, the malicious actor has also to record the signature of the firmware to the record transparency registry. So this is your second chance to detect the attack. And because we didn't have access to the certificate transparency registry, we only relied on the second step for detecting the attack. I don't know if this answered your question.
Yeah, thank you. So yeah, you specifically needed identity attestation, not just a commitment to having recorded some piece of information.
Yes, exactly, because the firmware users were verifying not only the integrity of the firmwares, but also that they were signed by specific identities.
So, how, from a practical standpoint, just stepping way back up to the user level, what does, how does a typical user who I'm hoping or guessing might not be, a general public user or something like, how does a typical user get all the confidence they need? How do they know whether identities are good? How do they do the verification, et cetera?
Yes, so this is all automatically handled by the Sigstore toolchain. So when you are invoking this toolchain, you are providing as input the desired identity as well as the identity provider that you are trusting. Then internally, the tools are communicating the tools receive there is a signature bundle that includes a certificate, this short-lived certificate. the tools validate that this certificate was issued to the identity you are trusting, and that this identity was verified by an identity provider you are trusting, and then they are communicating with this record registry, and they verify that the certificate was valid at the time this signature was generated. So
Yeah. No. So I hear that SIG-Store, the tools can do that. What kind of users are using this for installing what kind of firmware? In other words, how does a typical firmware is used everywhere. So is this a set of firmware users that already knows about SIG-Store, or do you have to educate them, or what?
No. So our use case were about smart grid providers, and they weren't aware, of course, of SIG-Store, but they were aware of the process of verifying digital signatures. And that's why we came up with this as a service process, because then the process of verifying firmware signature feels very similar to the traditional digital signature-based verification.
Very good. Thank you.
Yes, AJ, this is the project
Yeah.
I'm talking about.
Yeah. I know we're over time. Is it possible? Is there like a deeper? I saw a YouTube video. Is there like a deeper description of the security model and the other things? It seems we're asking about. Neil was asking about the things I was interested about too, but I don't expect you to be able to like explain it in 2 minutes.
Right.
Yes, but we are writing a paper about this. The deadline for the paper is in 10 days, and I will be very happy to share with you the submitted version, and even feedback from you will be super useful.
All right.
Fabulous. I love it.
All right. Well, I would keep this going, but I'm running a few minutes late to the next thing I have to go to, so I can leave people, I guess, if they want to stay, but I might have to hop off, or at least mute. So
Yeah, I have to drop
think
as
we're
well.
at time unless somebody else has something. Go ahead.
all right, go once, go twice. All right, thank you, everybody. This is fun.
Thanks, folks.
Great call. Thank you both.
Cheers, Al.
Bye.